Hello guys, welcome to this lecture which is made on functions actually. See, actually we were starting we were, in the previous lecture we were seeing about pointers. I think we finished with the basics of array, then we enter into the basics of structure, and then we saw about the basics of pointers, and we used pointers on arrays also, and we used pointers on structure also. So now we will be moving to function. We learned all the basics of array, structure and pointers in order to learn function. So coming to function, what we are going to see inside function is, first of all, what are functions, when function is required, and the second one is parameter passing, that if you have no knowledge about it, no issues, we will see now. There's something called as parameter passing, and inside parameter passing we are having three subtopics: pass by value, pass by address, pass by reference. Suppose somebody already who knows C might wonder, few people, that pass by address or pass by reference are both the same thing, right? No, they are not the same thing. They are different concepts actually. They are different concepts which I will just discuss in the upcoming lecture. Okay, fine. So we will just start with what are functions actually. See, when I was telling you about structure, I told you that structure are group of related data member. Group of related data member. I told you, right? What I told you, if I take rectangle, and what are all the data related to rectangle are grouped together. If you take playing cards, all the data member which is related to playing cards are grouped together. That is what the usage of structure. Similarly, I will define functions also. What are functions? Functions are said to be group of related instructions that perform that together perform a specified task. So we say that functions are group of related instruction, whereas structure is a group of related data member. Okay, group of related data member. Now functions are group of related instructions that perform a specified task. We will see how we are going to see. Similarly, I told you, I took a rectangle and I showed you that length and breadth are data member related to rectangle, and I took an example of playing cards and I showed you that face, shape and color are three data related to playing cards. Similarly, we will take few scenarios and I'll just make you understand what is this group of related instruction is all about. Okay, fine. So first of all, I'll just tell you why this function is required, why functions are required by programs. I think in the very second lecture I taught you about programming paradigms. In the second lecture I just taught you about programming paradigms. And in that programming paradigms, if you see, I told you many ways of style of coding is there, and the very major type of coding that I taught you is monolithic programming. And what I told you in monolithic programming is that the structure of monolithic program is that, for example, if you take a main function, the entire instruction will be written inside the main function itself. All the lines of code will be inside main function. I think so far we have seen that kind of problem only. We wrote Armstrong numbers, we wrote pattern programs, but all the instruction that we wrote for printing the pattern or finding whether a given number is Armstrong number or not, we wrote all the instruction inside main function only. Am I right or wrong? So whenever only main function is existing and all the instructions are written inside this main block itself, only main block, then that kind of coding is called as monolithic coding. I told you that monolithic coding is a very worst style of coding, because when a project becomes very long, what will happen is that you will be able to manage if the entire program is inside your main function, because the lines of code will be very large and you will be confused in between. In order to overcome this monolithic programming issue, the issue that is faced by monolithic programming, we are bringing in functions. We are bringing in function. In function, what we are doing? I'll tell you a scenario. I think this scenario already I have discussed with you, but again I'll tell you the scenario. For example, if you take a company, let me consider that there is a administration in the sense CEO. For example, a company is having a CEO, and let me consider that CEO, under a CEO, a manager is working. Under a CEO, a manager is working. And under a manager, okay, under a manager, nearly 10 employees are working. Under a manager, 10 employees are working. Okay, so a company is having CEO, and under a CEO, manager is there, and under manage 10 employees are there. For example, CEO is getting a project from some client. A CEO is getting some project from a client. So what CEO is doing is, CEO is forwarding the project to manager, and manager, he will not be able to do it himself. The work of a manager is not to do any work. The work of a manager is to manage these 10 employees. So manager will not be doing any work. He will be only managing these 10 employees. He will split the project into 10 equal parts, and he will assign the employees with the splitted project, 10 splitted sub project. So project is called as a task. A task is splitted into 10 subtasks, and the 10 subtasks are assigned to 10 employees. The 10 subtasks are assigned to 10 employees, and manager will not do any task. He will only manage these 10 employees. So what I will tell you is that a company, it means it's an entire program. Company means entire program. Manager means this main function is the manager. 10 employees, these 10 employees are going to act as like 10 employees are going to act like 10 different functions. So what will happen whenever you want to do a problem, then that problem has to be splitted into n number of subtasks, sub-problem, and the n number of sub-problem have to be written as a separate n functions, and manager should not do any work, which means that main function is not going to do any task rather than managing the employees, whose employee functions. So the work of main is to manage all other function, and it should not do any work by its own. This is the structure that I'm changing, and this structure only I was naming in the second video, that this kind of structure is called as procedural or modular programming. Okay, procedural or modular programming. Hope you remember all these things. So monolithic programming means only having main function and coding all the instruction inside main function. Okay, so that is a problem, actually drawback, and to overcome that drawback, we are introducing a concept called function, where what is happening, functions are acting as a important component of a program. So when a problem is given to you, then that problem you're splitting into sub problems, n number of sub problems. It is up to the problem. The sub problem may be 1 or 2 or 3 or anything. So you are splitting the given problem into n sub problem. Who is giving that? The manager is splitting and giving this 10 sub problems to 10 employees, and this manager is managing these 10 employees. So a main function will assign work to all the 10 functions, all the n functions, and this main function work is to only manage this n function. This will not do any work by itself. This structure is what called as procedural or modular programming paradigm. Okay, fine. So now what I will I think now you have a good idea of why we want functions, actually. Am I right? So now what I will do is we will write one example program, a very basic example program, and we will understand the necessity of functions. For example, the task given to me is, the task given to the manager is adding two numbers. Very simple task, adding two numbers. Now, coming to the monolithic coding, now I will write a monolithic code. Now I will write a monolithic code. Int a comma b comma c. A comma b is for storing two numbers. C is for adding the number and storing it. Okay, so a is equal to 10 and b is equal to 15, for example. And now what I will do here is, I'll just write c is equal to a plus b. C is equal to a plus b. And what I will do is, I will just print that c variable, the value which is inside c. Okay, see here, I told you that a main function is like a manager, and you know very well that a manager will not do any task. What is the task? Is adding two numbers is a task. So this is the task. C is equal to a plus b is a task. So hereafter, this is monolithic code because the entire concept is written inside main function. Now, if this has to be converted to a procedural or modular code, what you need to do? You have to take this function, you have to take this and you have to write it as a separate function. Okay, so now I will just give introduction to it. Just I have declared only a and b value in main function. The main function work is to just manage it. Okay, so I'm just only managing it. I'm not doing the task is adding it. So input getting, printing process, all this thing I'm going to do in the manager function, main function. But all the task will be it will be carried out in the function. For example, I will just write a function. I'll write a function. Now I will just give you a simple prototype kind of thing. Okay, I'll just give you a prototype. Prototype means the format how you should write a function. Okay, so I'll just write it here. See, a function has to be like, return type should be specified. I'll tell you what is return type, and the return type should be followed by function name. That should be a name for a function. That should be a name for an employee. Similarly, that should be a name for a function, followed by a parenthesis, and inside the parenthesis you should be having some parameters. I'll tell you what is parameters. Parameters like parameter 1, parameter 2, and you can keep on going up to parameter n. Sometimes no parameters also will be there, that we will see. Okay, parameters have to be given, and open close curly braces, and this is called as a body of a function. Okay, fine. Okay, fine. So this is just a simple format how to write a function. Okay. Okay, so now we will write a function. And what is the return type is all about? I'll just explain you what is return type, what is parameters, everything. That I'll give you example. Same example we can take. There's a company. Okay, in a company there is a manager, and under a manager few employees are working. Okay, this manager is assigning a work to his employee. That employee is what? This function. So when a manager is assigning some work, some task to the employee, you can just imagine. Okay, so the manager is assigning some work, and that, see, manager is the one who gets the project from the client. So manager knows well about the project. Actually, he knows very well about the project, what needs to be done, what should not be done. Okay, what features should be implemented in a project, what should happen inside the project. All these things manager only knows. So this employee might require certain information from a manager to do the task. A manager is there, a manager is assigning a task to his employee, and the employee will require some data from manager. See, a manager who knows about the project very well, and he is assigning a task, he knows about the task very well, and he is assigning a task to the employee, and this employee might require certain information from manager. Suppose if the employee requires certain information from manager to continue doing the task, then those data which is required by the employee to do the task is what called as these parameters. Suppose if this employee requires totally 5 data from manager, then parameter 1, first data need to be parameter 1. The second data which is required by the employee should be parameter 2. Third data required by manager should be, required by the employee from the manager should be parameter 3, and goes on, parameter 4, parameter 5. So parameters are the information or data that is required by the employee or by the function to execute a set of instruction, and those data are received from the manager. So parameters are the data required by the function to start doing a task. Next one. Okay, suppose if the employee requires certain information from manager, our employee receives all data which is required to start the task, and the information or data are if the data is information provided by the manager to the employee, by the manager to the employee, then the employee will finish the task, and at last you can see that you can do one thing. This person, after finishing the task, he will have some output with it. After finishing a task, definitely we will have output. Adding two numbers is a task. Resultant, you have added value. Multiplying two numbers is a task. After multiplying, you get an answer, multiplied value, output. If you want to find average, average is a task, procedure, and after finishing that task, you will have an output with you. So after finishing a task, you might have an output. That output, okay, that output, what you can do is that you might give it back to the manager. Some cases you might give the answer back to the manager, and manager will handle everything with the output that the employee is providing. Or sometimes the manager does not require any output from the employee itself can do the process with the output also. Some cases that we will see, I will show you few scenarios. So two things. One thing is, whenever a task is assigned by the manager to the employee might require certain information to start the task. Those informations are called as parameters. And second thing, after finishing a task, this employee will definitely have output, and that output can be given back to the manager, or as well as he can keep it himself. The employee can keep it himself. Okay, so that the output which is given back to the manager is what called as return type. So for example, adding two numbers, what has happened? Adding two numbers, you get a resultant answer. The resultant answer will be for example like integer. So if integer is the data, is the output data that you are going to return back to the manager, then your return type is integer. If suppose you are not returning, the employee is not returning anything to the manager, and the return type can be given as void. Okay, so this we will see we will see few examples so that you can understand it better. But now what I will do is just I'll show you few way. I'll just write a simple function to add two numbers. So first of all, what you need to decide is that always whenever you start writing a function, you need to decide about the return type and parameters. So return type and parameters are two important factors of a function. So first of all, just tell me, adding two number, what you are going to do? Whether you are going to return the value back to the manager? Yes, I am going to return the output. What is the output? Added value. The added value should be again given back to the manager, and my manager is only going to print that added value. So what I can do is that I can take integer as the return type, because I am going to add two integer numbers, so the resultant answer will be also integer. So the return type is integer, followed by the name of the function. Name of the function is add, because I am going to add. Okay, followed by a parenthesis, and I'll just open the body part also. Coming to this parenthesis, I need to decide whether parameters are there or not. Just tell me whether parameters are there. What is parameters? Information required by the employee from the manager. Is there any information that you require from manager? Yes, definitely. Which two numbers I need to add? Okay, if I know the numbers only, I can add and I can give the answer. So what are all the information required? Two information, A and B, and these two informations are integer informations. So what I need to tell is that I require a integer value, and it is not necessary that the same variable name should be mentioned here. I'll tell you reason why it is not necessary. And also you can have the same name also or different name also. It is up to you. But I'll tell you the reason why it is happening. But before that, I'll just take X, comma, int Y. So what I'm telling that I require two information from my manager. One information is an integer value called X, and the other information is integer value called Y. Okay, and this is generally called as this line. This line is called as prototype. This is called as a prototype, or it is also called as signature, and also this can be called as declaration of a function also. Declaration of a function, either prototype or signature or declaration. Now I'll just come inside this one. So let me consider that these two data from the manager are received by these two variables called X and Y. These two data which is required from the manager by the employee will be received using these two variables called X and Y. So now what I will do is I will take one more variable called Z, and what I will do is directly I will do X plus Y, and will store it in integer variable called Z. Okay, now the task is being carried out. The task is carried out, and after finishing the task, what is my next important thing? After carrying out the task, the next important thing is either I'm going to return it to the output is Z. Either the output is going to be again sent back to the manager, or I'm going to keep it myself. No, I'm not going to keep it myself. I will be returning back. I will be giving back the value to manager itself. How I have to return it back? Using a keyword called return. After followed by return, I should mention which value I need to return back. I need to return the value which is stored in the variable called Z. So I will give return Z. This return is a statement. It's like a control statement which will stop the execution of a function here itself. Whatever you write after this will not be executed. Whatever you write after this return statement will not be executed. It means that whenever a function is seeing return statement, return keyword like this, it stops its execution completely. Okay, fine. So now what I will do is, I told you that an employee should be managed by the manager, and you see here, so the two values are received by the manager from the client, for example. These two data are received from the client, for example, and you need to call your employee, and you have to say that you need to do this process called addition using these two values. Your manager has to call the employer. The manager has to call the employee, and he have to tell that you have to do this process, you have to do this task. This is a task assigned to you. How to do that? Using function calling. This is called as function declaration. Which tells that an employee should do this thing. This is the work of an employee. This is the employee, and these are the things that employee has done. And now as a manager, he have to call and inform. As an employee, as a manager, he need to call his employee and he has to inform that you need to do it. That informing process is what called as function calling. How to do the function calling? First of all, specify the name of the function, followed by parenthesis, and inside this parenthesis, you see here, your employee requires two data from you. The employee requires two data from the manager. So those two data which the employee is asking for should be provided to the employee. So what we can do here is, I can pass what data has to be passed. A and B has to be passed. So what you're doing, instead of X you are passing A, instead of Y you are passing B. This is how you call, this is how you inform your employee. So this is also called as calling a function. Calling a function. See, while in the prototype, if you see, you have to mention the data type of the variable, but here you need not to specify the data type of a variable. Okay, fine. So now what has to happen is this answer, the answer which is given back by your employee. See, your employee is giving back the value called Z. Okay, if you want to receive that value which he is sending, you need to have a variable here also, integer is C, or otherwise you can declare the variable C in this line, and here you can just give C is equal to add of A comma B. So now what happens, the added value is returned to the manager, and manager using one more variable receiving the value which the employee is giving back, and the given value, the value which is given back by the employee is stored now in C. It is received by using C. Okay, and now after this what I will do is, I will just print F, I will do %D comma C. Okay, hope you understand this manager employee relationship and all these things. Okay, so first of all what I will do is, I will just execute and show you the input is whether 10 plus 15 is 25 or not. Then we will get into parameter passing, because see here, this is parameter receiving, this is parameter passing. Okay, here only you are passing the parameter, and here the parameters are received here. So this is called as parameter passing. A value is passed from this place to this. So this is generally called as parameter passing. You're passing your value from one function to another function is called as parameter passing. Then we will get into parameter passing, but before that we will just check whether it is printing the right output or not. Okay, fine. So I'm just initiating the execution. Yes, execution is successful. Sorry, compilation, and compilation is successful. Now executing. Yes, it is printing me 25, which means that the entire process is happening perfectly. Okay, so whom you are interacting with? I am interacting with only the manager. The manager is only interacting with the employee. So I am a client who is interacting with the manager, and the manager is directly, you know, he is directly communicating with his employee. So we are only working with the manager. We have the communication between manager only. There is a communication between the client and the manager. Manager is whom communicates with this employee, manages his employee, and gets the work done. Okay, fine. That I'll show you how manager is only we are talking with. Okay, fine. So now I'll just show you the line by line process, and before showing you the line by line process, I'll just show you manually how this is going to happen. Then I will show the similar process line by line. Okay, I'll just take the main memory part, and I hope you know the main memory is split into three parts. One is code section, the next one is stack, and the next one is heap. And now I told you that whenever execution starts, the execution starts from the main function. Why it is starting from the main function? Because we are the client. We have only the direct connection between manager only. So I need to speak with the manager. So in order to speak with manager, I'm just calling this function main. I'm taking the phone and I'm calling to the manager, not to the employee. So the execution is not starting from this function. It is starting from main function, because main function is who is the manager. So once this point execution is starting, I told you that whenever execution is starting, the translated or the compiled code will be stored here in the code section. The .exe translated or mission code will be copied to the RAM, and it will be stored here in the RAM, because I told you that stack and code section both are actually a part of RAM. Okay, fine. After copying the executable file and storing here in the code section, then only our process start. What is the process? Starting our execution from main function. Whenever the main function is started to execute, the one activation area will be created. So now if you see, for a manager also, that will be a separate activation area. For the employees also, you will have a separate activation area. Now I will just take a activation area, and this activation area is the manager activation area. And inside this manager activation area, what will happen? What are all the information inside this is there with the manager, is with the main function. Those data will be stored here in this activation area. How many variables we are having? We are having 3 variables, including C. We are having 3 variables. So what will happen initially? Inside this, 3 block will be created called as A. A block called A will be created. Then followed by a block called B will be created, and then followed by a block called C will be created. And once this line is executed, once this A equal to 10, B equal to 15 is executed, C is not assigned with any value now. Once this line, 18th line is executed, what will happen? In these 3 blocks which is created inside the main activation area, which is created inside the main activation area, in the block that is created for variable A, 10 will be stored, and on the other thing 15 will be stored. C will not be stored with anything now. But before that, what we are doing in the next line, before assigning, see, after calling this function only assignment will happen. So what is the first thing that will happen? Add of A comma B, this function will be called. Now tell me one thing. I am a compiler. What I'm doing, I'm directly, I was calling only the manager. I was calling to the manager only. Now after calling the manager and informing that this need to be done, what he is doing, the manager is now calling his employee, who's called as add. I am not calling, we are not, the client is not calling directly. The client is calling to the manager, and now the manager is only calling his employee. So now what will happen? Once his employee called add, the function called add is created, what will happen is that the entire call is not still over. The entire process is not still over. When a process will be over? A process is said to be over, the scope of a function. The scope of a function is said to be over once the closed curly braces of the entire function is being executed. When the closed curly braces of the entire function, if it is executed, then only the work of a function will be over. Okay, so once, see, whenever I see this open curly braces, the activation area will be created. Whenever a open curly braces of a function is seen, then a corresponding activation area will be created. Activation area will be created. Now whenever I'm seeing the closed curly braces, then what will happen? The activation area which was created will be deleted. Once the entire line of functions are executed, then the activation area which we created will be deleted. Okay, fine. So now what I will just tell you is that I'll just show you what will happen now. So whenever you're calling this function, I think still all the lines of main function is not still over. Since all the lines of execution are not still over for main function, this activation area which is created for the main function cannot be deleted, because I told you that when an activation area can be deleted, when all the lines of a particular function is executed properly, then only uh, the activation area can be deleted. Now still few lines are there. So if only these few lines are executed only, I can able to delete the activation area which is created for this main function. But for until that, what I need to do, once this add function is created, whenever you're calling one more function, and if the function is called, what will happen, your control will go to this line. Once your control is gone to the other function, what will happen, one more activation area for this add function will be created. But one thing, if you see here, the existing activation area is not deleted so far. So what has to happen is one more activation area has to be created, but on top of a existing activation area. On top of existing activation area. So now what I will just show you is that I will just create one more activation area, and that activation area will be created on top of the existing activation area. So this new activation area is called as add activation area, because this activation area is created for the function called add. And now tell me what you have passed here. You have passed a value, right? A and b value. You have passed a and b. So what is the value of a? The data of a is 10. And what is the data of b? B is 15. These two, 10 and 15, you are passing it to the two new variables called x and y, and these two variables called x and y now will be created inside this activation area called add. Now you can go and you can say that two variables are created here, three variables, because you see here inside this function integer x is the parameter, is also one of the variable that for which memory will be allocated. So integer x, integer y, and integer z. So totally three variables are there inside this function also. So now what I can tell you is that x will be having a block allocated with a block, and then you will be having y, and that also will be allocated memory with, and then finally you have z, that also will be allocated memory with. Okay, so now what will happen, since you are passing the value of 10 and 15 from main function to add function, this data is copied from here and it is sent to the variable called x. And then the same data called 15 is in the same manner, it is also passed to y and it is stored there in y. Now we can clearly see that these are two different activation area and these are two different blocks. X is a different memory block and A is a different memory block. That is why I told you, you can have a different name here or also the same name. If you have the same name A and B, what will happen? This block will be having the name called A and this will be having the name called B, even though the same name is given, but they are different memory block of different activation area. Okay, this is object in one room, this is object in another room. Even though both are having the same name, they are different, they are in different location, they have different memory locations. So you can have same name or you can have different name, no matter whatever it is. And now inside this function, what you are doing, you are adding x and y and you are storing it in z. So what will happen here, the x and y value is added and the resultant value 25 is stored here in z. You add the value of x and y and store the resultant answer in z. Okay, so now what is happening here, the next line is return z. So once I told you that whenever return statement is seen, what will happen, then the complete execution of the function will be over. So what I can tell you is that if close curly braces is seen, then the activation area will be deleted, or otherwise if return statement is seen, then also the activation area will be deleted. So what I can tell you is that here, once it is seeing the return statement, first of all, it will copy this 25 temporarily. It will take, because this is what you are returning, the z value only you are returning. So this 25 will be temporarily taken and it will be, the compiler will be holding it. And once the return statement it is seeing, it will copy 25 temporarily and it will delete this activation area. because I told you that whenever the complete line is executed, then the activation area is deleted. So all the lines are executed, so activation area is deleted, and it will come back to the line. It will come back to the line where from where I went to this function. I'll just come back to the same line from where I go to the function. And now what happens, I still have the value 25 in hand. One value that I copied from that activation area is 25. That value is still in hand, and that value which is returned from here will be now stored here in is a C. So now what will happen, the variable called C, which is in main function, will be receiving that value which is copied from the above activation area, and now after doing this, what will happen, the next statement is printf. So now what is the C value? C value is 25, so 25 will be printed, and once this last line curly braces is executed, what will happen, the activation area of the main function also will be deleted. So what will happen, this activation area also will be deleted, and the code which is here also will be deleted. The code which is stored here also will be deleted. So the complete execution is over. So when the execution is starting, the file is copied to the code section, activation area for main is created, and the main function is calling one more function, so one more activation area is created on top of it. And once all the lines of add function is over, then that activation area is deleted. Then I again come back to main activation area. So this section is called a stack. For what reason this is called a stack means, because you are creating the stack one above the other. You are creating the stack one above the other like a stack, and you can able to see that always the activation area, the topmost activation area is the active activation area, which means that when main is there, main was active, but once add activation area was created, the flow and the control was there in the add activation area. It was not with main. So the topmost activation area is having the power, is the active one. Suppose if I need to access something from main activation area, then the add activation area have to be deleted, then only I can come back to the main activation area. So the topmost activation area is having the highest priority. So you can say that the last created activation area, which will be on the top of the stack, and that topmost activation area will be always the first given. It will be given with the first priority. So generally what is called a stack means first in last out, or otherwise last in first out. So you can say that whichever activation area is created last was deleted first. You can say that main activation area was created first, then only add activation area was created. Which was the first activation area to be deleted? Main. So whenever the last created element is deleted first, then it is called as stack. So you can say that this memory section is behaving like a stack. That is the reason why this memory area is given the name called stack. We will see about stack in the later part, but now so far what you need to understand is, you need to understand the creation as well as the deletion of the activation area, which I will show you now. We will just go for the line by line execution starting from main function. I'll just show you here. So I'm just invoking the line by line execution. Where the execution will start? The execution will start from this main function, from the manager. The client is calling the manager. So now what will happen? A main activation area is created. See here, activation area for main is created, and now I will you see here what is inside the main activation area. You are having three block called as A, B, C. Three are having random garbage values. Now I will execute the 18th line. The 18th line executed. What is happening? A is having 10, B is having 15, C is not still assigned with anything, so it is having not 0 garbage value. Now what is the next line? Next line is a function call. Now whenever a function is called, what will happen? The flow will go to the 9th line, for example here. So now I'll just go to the flow. So I have entered into a new function, and can you able to see here? There was an existing main activation area, and on top of it a new activation area called add was created. And now if you see inside your add, if I click on add, inside your add you're having three variables called x, y, z, and you can see directly x is copied this 10 value, so 10 is passed to x, so 10 is receiving 10, x is receiving 10 and storing it, and y is receiving 15 and storing it. Now z is not still assigned with anything, but I can show you the difference between both the activation area. When the add activation area is clicked, it is showing you the variables which is inside add activation area. If I click on main, main is storing it is telling you ABC. So inside main we are having ABC, three block ABC, and in add I am having three different blocks called XYZ. So can you able to see the see that both are different activation area, both are having different variables, actually separate variables. Now what I am going to do is that I will just simply tell you that I will just change you I will just execute this 11th statement. So x plus y is added and it is stored in z25. And now what is the line we are seeing? Return z. So if I execute return z, where the flow will go to, the flow will again go to 19th line, and it will return the z 25 will be stored in z, and the flow will go to 20th line. So once it returns C, it is sent to the last curly braces of the same function, and then it is sent again back to the main function. Okay. Now if you see, since all the lines of the add function is over, the add activation area which was there, if you see, now it is missing because it is deleted, because all the lines of the code executed, then the respective activation area have been deleted. Now if you see the value of C, the returned value 25 is now stored in this variable called C25. Now what is going to be the next line? Print. So automatically I will just print this value called 25. I'll be just printing the value of 25, and automatically when this last line 21 executed, what will happen? This main activation area also will be deleted. Here you can see all the process is now over. All the process is now over. Okay, so can you able to see that understand the creation of activation area and deletion of activation area, right? So the main reason why we are seeing this is called as parameter passing. See, why this is calling a function, this is declaration. So the parameter that you are passing in the calling time, when you are passing it in the calling time, these parameters are called as actually actual parameters. Actually it is actual parameters. So while calling, if you are passing a parameter, this parameter is called as actual parameter. This in the receiving place, this parameter is called as it is called as formal parameters. Formal parameter. It is called as formal parameter. Okay. So now what I need to tell you is this is actually a function. Still now we have not come to the type of, see if you see here, parameter passing, what are function, we have seen only what are function, and coming to parameter passing we have seen only that these are actual parameters. A and B are actual parameters here, and here int x and int y are formal parameters. Up to this only we have seen so far. In the next lecture, okay, I think this session has gone for nearly 50 minutes. So 10 o'clock we started, and now it will be nearly 10:47. So what we will do is, again we will take a 10 minutes of break, and we will start the next session by 11 o'clock. And in that session we will see about the types of parameter passing: call by value, call by address, and also call by reference also I will be dealing with. Okay, fine. So thank you. This is for the session. I think this will be very useful for you, and it will be really happy for me if you people are understanding this the better way. Okay, so thank you, and thank you guys for following the entire course. There are a few people who are following the entire course. Each and every video you are following it, and this is keep going. Okay, keep learning new things day by day. Okay, thank you.